In 1960, the Aral Sea was the fourth largest lake on Earth. It held more than 1 trillion cubic meters of water, a number that becomes real only when you translate it. Enough fresh water to fill Lake Erie 14 times over. Spread across an inland sea larger than the state of West Virginia, ships disappeared over its horizon. Fishing ports on its shores exported 40,000 tons of fish every year to feed the Soviet Union. By 2007, 90% of that water was gone. Not from drought, not from any geological shift, from a single administrative decision made in Moscow. And the strangest detail, the part that inverts every expectation, is that part of it is coming back. Before we go further, if you're the kind of person who actually wants to know what they don't teach in school, hit subscribe right now. We go this deep on every single video. The Aral Sea sits in Central Asia, on the border between what is now Kazakhstan to the north and Uzbekistan to the south. For thousands of years, it was fed by two of the longest rivers in the region, the Amu Darya, flowing in from the south, and the Syr Darya from the northeast. Both rivers carried snowmelt from the Pamir and Tian Shan mountains across hundreds of miles of desert and steppe, filling a closed inland basin with no outlet to any ocean. The system held its equilibrium across millennia. What we are going to trace, in 6 stages, is how that equilibrium was deliberately broken, what the land and the people became when the water disappeared, what was discovered on the exposed seabed that no investigator expected to find, and why one half of the Aral Sea is rising again while the other is being turned into a desert forest. In 1960, the Aral Sea held more than 1 trillion cubic meters of freshwater, enough to fill Lake Erie 14 times over, and its fishing ports shipped 40,000 tons of fish per year to the rest of the Soviet Union. That is not background context. That is the measure of what was destroyed. The sea covered 68,000 square kilometers of Central Asia. Picture it this way. The land area of West Virginia, filled to a depth of 68 meters in the north. The Aral was not a shallow lake that could be drawn down by a difficult season. It was a continent's inland ocean. And it did not merely store water, it shaped the regional climate. Winters along its shores were measurably milder than the surrounding steppe. Summers were cooler and wetter. The sea distributed atmospheric moisture across a radius of hundreds of kilometers, making agriculture viable in terrain that would otherwise be too harsh for most of the year. The towns of Aralsk in the north and Minok in the south were not fishing villages. They were industrial fishing cities with canneries, shipyards, and dedicated railway infrastructure built to carry fish to markets across the Soviet Union. The crews went out on diesel trucks. They came back with carp, brim, pike perch, and sturgeon. Tens of thousands of families built their working lives around the water, and had been doing so for generations. Consider what that represents. A sea in the middle of one of the most arid regions on Earth, sustaining industrial cities. The Aral was not just water, it was the ecological infrastructure on which a civilization had organized itself, and everything rested on 2 rivers, bringing snowmelt in from the mountains, the Amu Darya from the south, the Syr Darya from the northeast. As long as those rivers reached the sea, the balance held. The fishermen of Minok had no reason to believe the rivers could be turned away. They had arrived long before any living memory. The decision to turn them was made in Moscow by planners who had never stood on the Aral's shoreline, and who looked at those 2 rivers and saw not the source of an ecosystem, but the raw material of an agricultural empire. What came next was not an accident. It was a plan. The diversion of the Amu Darya began in the late 1950s. The Karakum Canal, built to carry river water into the cotton fields of Turkmenistan, stretched over 1,300 kilometers when complete, one of the longest irrigation canals ever built. Soviet state media documented its construction as a triumph of civilization over geography. Officials called the resulting harvest white gold. Cotton tonnage climbed with every 5-year plan. By the 1980s, the Soviet Union had become one of the world's largest cotton exporters, and Central Asia was producing the fiber that clothed much of the Eastern Bloc. The Aral Sea, meanwhile, was disappearing by the decade. Surface area in 1960, 68,000 square kilometers. By 1970, 55,000. By 1980, 40,000. By 1990, 30,000. Each decade, a Connecticut-sized body of water was ceasing to exist. And as the volume shrank, everything dissolved in the remaining water, concentrated. The sea that had once registered roughly 10 grams of salt per liter climbed past 30, then 50, then 80. At 35 grams per liter, most fish species cannot survive. At 50, the water is functionally dead. Stop and translate that into physical reality. The docks in Erelsken did not gradually run short of fish. The water simply retreated, not by meters, but by kilometers, within the span of a single working generation. The trawlers were not relocated to deeper harbors. There were no deeper harbors. The ships were abandoned where they sat as the shoreline withdrew, left standing on what became open desert. Those rusting hulls, surrounded by sand with no water in any direction, became one of the defining images of 20th century environmental failure. The fishing economy, 40,000 tons per year, the livelihoods of tens of thousands of families, was gone by the mid-1980s. Canaries in Minac began importing fish by rail from the Pacific Ocean, 2,000 miles away, to keep their processing lines running. Workers were packing fish from the other side of the continent in a building that stood over 100 kilometers from the nearest water. The irony, if dignity allows the word, is that the cotton program was simultaneously destroying itself. The irrigation systems were inefficient at a fundamental engineering level. Much of the diverted water never reached the fields, lost to seepage through unlined canals and evaporation in the desert heat. The soil in the irrigated zones was becoming waterlogged and salt-crusted. The white gold was poisoning the land that produced it, even as it drained the sea that had sustained the region for thousands of years. The wind picked it up. The exposed seabed was not clean sand. It was a sedimentary archive of 4 decades of agricultural runoff pesticides, herbicides, and defoliant compounds that had entered the Amudarya and Ciudaria from the cotton fields and settled in the lakebed sediment. When the water pulled back, those compounds remained on the surface. Dust storms, dozens per year, lifted them and carried them hundreds of kilometers downwind. Children in surrounding communities developed respiratory illnesses at rates that alarmed Soviet physicians. Infant mortality in the Aral zone reached levels among the highest in the entire Union. The health ministry classified the data. The cotton quotas did not change. By 1987, the sea had split. The retreating water left a land bridge across its center, permanently dividing the basin into the small Aral in the north and the large Aral in the south. 2 bodies of water. 2 different futures, and one discovery still buried beneath the southern floor that would reframe the entire disaster. By the early 1990s, an island near the center of the shrinking large Aral had become a peninsula. The water had retreated far enough that Vozrozhdenia Island was now connected to the mainland by a strip of exposed seabed. That would have been a geographic footnote, except for what had operated on that island since 1954. The Soviet Ministry of Defense had run a biological weapons testing facility on Vozrozhdenia for decades. The island's isolation was the point. Surrounded by water on all sides, accessible only by controlled boat passage, it provided a natural quarantine for testing weaponized anthrax. Plage, brucellosis, tularemia and other agents on live animals. When the Soviet biological weapons program was officially disbanded in the early 1990s, under international pressure, the facility was abandoned. T materials, anthrax cultures, plague samples, smallpox residues were not fully neutralized. Some were buried in open-pit graves. Some were left behind. The island is now a peninsula. The water that made it an island no longer exists. The geographic containment, the moat that held the testing site in isolation, is gone. Rodents and other animals move freely across the land bridge between Vozrozhdenia and the surrounding steppe. American scientists who visited the site in the late 1990s found anthrax spores still viable in the soil. More than 40 years after deposition, a U.S.-funded remediation effort in 2002 attempted to decontaminate the primary burial sites. Whether the neutralization was complete remains, in official scientific literature, an open question. That is what was on the island. What was under the seabed was something entirely different, and, in its own way, more disorienting. When archaeologists and geologists began systematic surveys of the exposed large Aral floor in the early 2000s, they expected to find salt crusts and chemical residue. What they found instead were cities. The foundations of medieval settlements identified as part of the ancient Khorazm civilization, dating to the 11th and 12th centuries, had been preserved in the sediment beneath the former lakebed. Building foundations, artifacts, coins, the outlines of streets. An urban civilization that had been submerged when the Aral Sea rose centuries ago was now exposed again by the same process operating in reverse. The sediment layers around those ruins told a story that no one had anticipated. Pollen records and geological stratigraphy showed that around the 9th and 10th centuries, the Aral Sea had nearly disappeared. Not because of irrigation, not because of any human action, but because the Amu Darya had naturally shifted course, temporarily redirecting its flow away from the Aral Basin. Civilizations had built cities on the exposed floor. The river had returned. The sea had risen. The cities were submerged, and now, 1,000 years later, the water had pulled back again. The disaster is human-made. The rate and totality of the Soviet-era collapse is without natural parallel. But the system itself had experienced near disappearance before and had recovered. The ecological clock of the Aral Basin ran not on the timescale of 5-year plans, but on the timescale of centuries. What Soviet planners compressed into 40 years, natural variation had once spread across hundreds. That single fact that this system had a history of self-recovery was the first scientific basis for believing that intervention, under the right conditions, might be possible. But the most unsettling part is still ahead. If what you just learned bothered you, good. That means you're paying attention. Subscribe so you don't miss what comes next. Because what we're investigating in the next video makes this look like the introduction. The northern portion of the divided sea, the small Aral in Kazakhstan, had one structural advantage over the south. The Sea Darya still flowed into it, however weakly, and the northern basin was shallower, which meant that even a modest increase in inflow could raise the water level meaningfully. Kazakh engineers, working with World Bank funding, identified a precise intervention: a dam across the Berk Strait, the narrow channel that had connected the northern and southern basins, through which water was continuously draining south into the deeper, more rapidly evaporating large Aral. The Kokarul Dam, 13 kilometers of earthen embankment and concrete, was completed in August 2005. Total cost, $86 million. Within 8 months of completion, the water level in the small Aral had risen by 3 meters. By 2008, the surface area had recovered by roughly 40% from its lowest recorded measurement. Salinity dropped from 30 grams per liter to under 10, back within the range that native fish species could tolerate. In 2006, the first commercial fish harvest in the small Aral in decades was recorded. The town of Arelsk, whose shoreline had retreated more than 80 kilometers since saw water returning to within a few kilometers of its former harbor. 13 kilometers of dam, $86 million. 18 months of construction, and a sea that had been dying for 50 years began, visibly, to breathe. The south is a different calculation. The large Aral on the Uzbek side receives no equivalent intervention. The Amu Darya's flow remains largely diverted. The southern basin has effectively ceased to exist as a body of water. It has become one of the youngest deserts on Earth, covering approximately 60,000 square kilometers of exposed former seabed. The name combines Aral with kum, the Turkic word for sand. The Uzbek government's strategy for the Aralkum is not restoration. It is containment. The tool is the saxol tree, a drought-resistant species native to Central Asian deserts with a deep root system that anchors salt-contaminated soil against wind erosion. Since 2018, more than 1 million hectares of saxol have been planted across the Aralkum floor. The goal is not to bring the water back. The goal is to prevent the toxic dust storms from intensifying, to stabilize the exposed seabed so that the communities downwind of it, which have been breathing its chemical residue for 40 years, face no further escalation. It is not what you would call a recovery. It is what you call an adaptation to a permanent loss. The The two halves of the former Aral Sea no longer share a scientific name. One is the North Aral Sea. The other is the Aralcum Desert. One is rising. The other is being replanted. Both outcomes were chosen. Aral Sea disaster is studied in environmental science as a case of closed basin hydrology failure, but that framing is clinical in a way that understates the mechanism. A closed basin lake has no natural outlet. Its volume is maintained entirely by the balance between inflow and evaporation. Reduce the inflow below the evaporation rate, and the lake shrinks until it reaches a new equilibrium, or until it disappears. The Aral's inflow was not reduced gradually through competing regional demands. It was reduced by approximately 90%, deliberately and within 2 decades. No closed basin lake of comparable size had ever experienced that rate of drawdown from managed diversion. The Aral became, without being designed as one, the largest hydrological experiment in human history. The public health consequences extend far beyond the former shoreline communities. Dust from the Aralcum carrying salt, organochlorine pesticides, and defoliant residues has been detected in Arctic ice cores and Himalayan glacier samples. It appears in blood samples from children in communities hundreds of kilometers from the former shore. Anemia rates in the Aral region remain significantly elevated decades after the sea's disappearance. The World Health Organization classifies the Aral Sea Basin as one of the worst environmental disasters of the 20th century, not primarily because of the ecological loss, but because the human health consequences are still acute. The recovery of the North Aral has become a reference case in environmental science for a specific reason. The fish populations did not require reintroduction through stocking programs. They returned from residual populations that had survived in the Sir Daria River channel within 2 years of salinity, dropping 2 survivable levels. The biological memory of the system, the species, the food chain relationships, the ecological connections, had not been erased. It had been suppressed, waiting for the chemistry to shift. Consider what that means for how we understand ecological damage. The archaeological evidence on the seabed added a structural dimension to that understanding. If the Aral had experienced near disappearance under natural conditions and rebuilt itself across centuries, then its resilience is written into the basin itself, into the geology, the river connections, the sediment biology, not dependent on any particular water level or any particular human decision. What the Soviet intervention compressed into 40 years, natural variation had once stretched across hundreds. The recovery, where conditions allow it, may run on a similarly compressed timeline because the infrastructure of the ecosystem did not leave when the water did. One administrative decision, made in Moscow in the 1950s by men with maps and no witnesses, erased 1 trillion cubic meters of water from the face of the earth. 70 years later, a 13-kilometer dam, built by engineers with different maps and the same concrete, is writing part of it back. Not all of Italiano. The southern half is gone on any human timescale, and the generation that watched Minax Harbor become a desert will not see a sea return. But the north is rising. The salinity has dropped. The fish are back. The children of fishermen's children are catching pike perch from boats in a harbor that their grandparents watched become sand. What that tells us is not simply that nature recovers when pressure is removed. It tells us something harder, that the same civilization capable of erasing a sea in 4 decades is also capable of beginning to write it back, not through guilt, not through sentiment, but through engineering. Once it finally accepts that the cause was specific and the damage was specific, and therefore the response could be specific. The fishermen of Minack are still waiting in the south. Their ships are still in the sand. Some decisions outlast the people who made them. This is the kind of history that never makes the front page. Subscribe, and we'll keep finding it together.